Okay, so last class I have given you some introduction to angle modulation, right? Okay. Now we have seen some theory behind angle modulation. Now see here, this is a wave, this is a carrier wave. In this carrier wave equation, you can see theta is a function of t, right? The entire theta of t, we will make it as a proportional to the amplitude of the message signal. That's what we are doing it. Okay. Now see here, let theta be is the phase angle of a carrier which is made proportional to the modulating, that is message signal m of t. So let theta t be equal to omega ct plus phi t. So what is omega c? Omega c is the angular frequency of the carrier, right? Now the theta of t, you see it is omega ct plus phi of t, right? Now substitute the same thing in the equation 1. What you get is c of t is equal to AC cos omega ct plus phi of t. Right? Now see, this phi of t, it depends on instantaneous value of the message signal. Right? See, omega ct is constant, right? Your frequency of the carrier wave, that is omega c, is constant. You are generating a carrier wave of say frequency 50 hertz. That remains same. Right? Now when you modulate it, your effective frequency, effective angle, phase angle is equal to omega ct plus phi of t. The phase change, whatever phase change happening with respect to your omega ct, that is what actually proportional to the message signal. Try to understand this. Okay, you have, suppose if I say, try to understand this, if I say c of t is equal to AC cos of omega ct, can you tell me what is this? Tell me. This is a carrier wave, right? This is a carrier wave with the frequency of the carrier wave is equal to omega c, or else fc hertz, which is in terms of 50 megahertz, 60 megahertz, 70 megahertz. Right. Now what I do in angle modulation is that I will change this to omega ct plus phi of t. Now where is the information about your message signal? Which component of this has the information of the message signal? This phi of t, I can put it in this, right? I can exploit that. I can make phi of t proportional to m of t. I can make this phi of t proportional to m of t. And what is that m of t? Your, nothing but your, what is this? This is your message signal. This is your message signal. That's what we are doing in this. Right? So this phi of t, I said phase angle varies proportional to the message signal. So total phase angle, it varies. Ultimately what is going to happen to carrier wave? Your entire phase angle of the carrier wave will vary according to the message signal. Now we are talking about phase angle. So how do you convert your phase angle to frequency? There is something called instantaneous frequency, right? Listen carefully. See, this entire thing is written in terms of theta of t, right? This is phase angle. This is instantaneous phase angle. How do you convert it into instantaneous frequency? If I say, tell me in terms of frequency, that's where the relation is. Rate of change of phase angle will give you the frequency. Okay, try to remember this concept, which are very important. See, so instantaneous frequency is equal to d theta of t by dt. Now in our case, what is theta of t? It is omega ct plus phi of t, yes or no? So now theta of t is equal to omega ct plus phi of t. Now you will get omega it is equal to, that is instantaneous frequency of the modulated wave, is equal to d of omega ct plus phi of t dt. Which is constant in this, tell me? Omega ct is constant, right? Phi of t is the one which is having, right? Omega c is constant. Okay. Now, after differentiating this, can you tell me what you will get? It is d by dt of omega ct plus d by dt of phi of t, yes or no? Right. So, what is d by dt of omega ct? Omega of 0. Omega c is constant, correct? Omega ct is there, no differentiation, right? Omega c, yes or no? So, you will get instantaneous frequency is equal to omega c plus d phi of t by dt. Now, can you tell me now what is depending on message signal? Omega c is constant, right? So, which term in this depending on the message signal? Phi of t, yes or no? It depends on phi of t, yes or no? All of you agree that I told you, right? Now, you see what I will do now. I will say this component d by dt of phi of t, the frequency component depending on the instantaneous value of the message signal. Now, if I make this proportional to the message signal, okay, I'm getting you the angle modulation there in terms of frequency, and I call it as a frequency modulation. I have understood this, okay? So, this is what the concept is, okay? So, here instead of amplitude, we are touching upon the angle of the carrier wave, and which part you are going to touch with respect to the constant frequency, and this particular phase change is now proportional to the message signal. Have you understood this now? Okay. Now see, now this is the frequency. I call this as a frequency. I'm not calling this as a phase change now. If I write phi of t, that is phase. Remember carefully. If I just write phi of t, that is phase. What is d by dt of phi of t? Frequency. So, your instantaneous frequency of an FM wave after modulation is your carrier frequency plus d by dt of phi of t. And what is this phi of t depend on? This phi of t depend on the message signal. Have you understood this? Right? So, can you tell me, I will go back to your AM, what we did in AM with respect to the same carrier wave? Why I am bringing back AM here is to make you understand, because you have already done AM, right? You have a carrier wave AC cos omega ct, right? What you did in AM wave? Come on, you should remember this. I have covered this. What you have exploited, this is the carrier, right? So ultimately we are transmitting carrier only. So what you did for AM wave? Exactly, come on, you are right. You made AC plus m of t cos of omega ct. This is for AM, right? You have exploited this person amplitude of a carrier to send you a signal. Now, in a similar way, what you are doing in angle modulation, you are exploiting frequency. That's all. Your carrier wave, when it is generated, it is AC omega ct only. This is constant now. You are not going to do anything with this, but you do something with this. This omega ct will be now equal to omega ct plus d of phi of t by dt when you write in terms of frequency. Have understood this? Have understood this? Okay. Of course, when you write in terms of frequency, this t will not come. Okay, t will not come. Okay, you are seen here. It is omega c plus d phi of, that's the frequency when you talk in terms of frequency. When you talk in terms of phase, your carrier will become omega ct plus phi of t. This is phase. Have you understood this? This is very important for you to remember in terms of frequency. See here, listen carefully. Listen carefully. You can write any wave. I will write AC cos of omega ct, right? What is this? Tell me now. This is a carrier wave, right? I have understood this. Okay. Now, this omega ct is called as angular frequency. It's called angular frequency, where omega c is the angular frequency when you talk about frequency. Actually, it is AC cos of theta. Theta is cos of theta only, because this is the entire cos, it is theta. We are writing in terms of frequency with respect to time, right? But actually it is cos of AC cos theta, right? Now what is omega c in this? Omega c is equal to nothing but d theta by dt, that's all. In this omega c, whatever you are writing here is d theta by dt. See, this is where we bring in concept of frequency in the sine wave, right? Otherwise, what is sine theta? It's a rotating vector, right? It's a rotating vector, right? So if you plot this versus theta, you will get this, yes or no? I'm just bringing back the fundamentals here. So this is your 0, pi, 2 pi. This is theta. Can I write same in terms of omega? I can do it, right? If you want to do it in terms of omega, you just differentiate this, that's all. You get it in terms of omega. So your omega is equal to, suppose if a frequency is omega c, it is d theta by dt. Have you understood now how you actually represent same angle in terms of frequency and frequency in terms of angle? Have you understood this fundamental? If you understand this, we can easily represent the equation for frequency modulated wave. Like you have done equation for amplitude modulated wave, you can write the equation for phase modulated wave and also frequency modulated wave, where one is differentiation of others and other is integration of one, right? Try to understand, this is very important concept now. Now see here, I am going to write this same carrier wave as either AC cos of theta of t, which is your instantaneous angle. Similarly, AC cos of omega it, that is in terms of frequency, right? That's what I am going to write here. Now see what next. I told you that this particular component, okay, in the previous equation, see here I told you this is your instantaneous frequency of the wave, right? This is the instantaneous frequency of the wave, right, after modulation. Now here this is constant carrier frequency. This is what depends on your signal, your message signal. So if I say this is proportional, if I say this is proportional to the message signal m of t, so I can just write this d phi of t by dt is equal to some proportionality constant, okay, m of t, yes or no? Yes or no? So I will directly write that. There is no harm in writing that. So what I will do, I will write your d phi of t by dt is equal to kf into m of t. What is this kf? This is called as proportionality constant. When you write in terms of instantaneous frequency, this is called proportionality constant. Frequency modulation, proportionality constant. Have you understood this? Hmm? See, now you have the equation, right? From where you started? You have the equation, right? Now, see, your equation for frequency modulated wave, you all started from AC cos omega ct, right? And this omega, this you write in terms of theta of t. This is equal to omega ct plus d phi of t by dt. Yes or no? Now, when you write in terms of, this is your instantaneous angle, right? Now, what is the equivalent frequency? Wi of t, instantaneous frequency, is equal to omega c plus d phi of t by dt. What is d phi of t by dt? It is proportional to the message signal, that is kf into m of t. So just substitute it here, that's all. Instead of omega ct, you will have the entire frequency is equal to omega c plus kf into m of t. See. Fine, I have understood this. See here. So when this d phi of t by dt is equal to kf into m of t, what is phi of t? Tell me. This is frequency. Suppose if I want to convert it back to the phase angle once again, integration, right? What is phi of t? Phase angle. The phase angle, you convert it to frequency, it is d phi of t by dt, right? Now when it is converted to frequency, how do you get it back to phase angle? Integration, that's all. See, how do you get the phi of t for this? It's quite straightforward, right? I need not tell you, you have done mathematics more than me. Then what is phi of t? Phi of t is integration from minus infinity to t. This is going to be phi of t. So now you got phi of t, phi of t. Right? That instantaneous frequency change which is happening in your FM wave, okay, when it is depending on your message signal, when you represent in terms of frequency, it is kf into m of t. When you represent in terms of phase angle, it is kf into integration of m of tau into d tau. Now, can I get the complete equation now? Right. So, complete equation is equal to, now complete equation is equal to AC cos omega ct plus phi of t. Yes, so this is what I said. Right. Your angle modulation is nothing but the carrier which was unmodulated, your omega ct will become omega ct plus phi of t. And this phi of t, I told you, it's proportional to your message signal m of tau. I understood this. Okay. This is a general equation for your angle modulated wave. This is the equation for angle modulated wave. Now it is left to you whether you make this equation or keep this equation in terms of phase change only, or you keep it in terms of frequency component. Right. Now for phi of t, right, you have an expression for phi of t right now, right? Yes or no? If you want to see the instantaneous angle, right, you have some representation for phi of t, right? If you want to see the instantaneous frequency, you have another representation for in terms of phi of t, right? That means we can split this equation, one to represent it as a phase modulation, one to represent it as a frequency modulation. Both are same. This is your angle modulation, okay? Try to understand this. This is angle modulation. Now this equation, I can write it in two ways. with respect to phi of t, with respect to phi of t, right? So in that case, I get two equations, yes or no? So one is in terms of only phase, one is in terms of only frequency, right? So how you write that equation? Okay, you already know about it. Now see here, substitute the value of phi of t. You want to write it in terms of only frequency, right? Omega c t plus phi of t, right? What is phi of t when you write in terms of frequency? See, d phi of t by dt is equal to frequency, right? What is frequency? What is phi of t in that case? If you want to write in terms of frequency, integration. Yes or no? Come on. If you want to write this equation only in terms of frequency modulation, you have to write frequency equivalent of phi of t. Yes or no? Have you understood what I am trying to tell you? So what is the frequency equivalent of phi of t? Phi of t is equal to kf into integration of m of t. Have you understood? Okay. When you write the same equation in terms of frequency, we call that equation as equation of a frequency modulated wave. Okay. And when you write that only in terms of phase, okay, we call that equation as phase modulated wave, phase modulated wave, right? We can write this equation either like this, okay, or else you can directly write your phi of t is equal to kf into m of t. That is phase modulation. I'll write only the phase. Have you understood this? Okay. So you have two representation now. One is phase modulation, frequency modulation. Both are same. Okay. Both are same. Both are same. See. So those who are not understood, once again I will explain you so that you can understand. Don't get confused. See, from where exactly we have started? We have started from a carrier wave, right? And you know, we are not going to touch this, right? And we are going to touch only this. And what is this? This is nothing but a frequency of a carrier wave. And this frequency of the carrier wave, now we are varying according to the message signal, instantaneous message signal, right? Now let us play with only this. So what I am going to consider this as a theta of t, right? So this omega ct, whatever is there, I will make it omega ct plus phi of t. That is going to be theta of t. Have understood this? Right? And this depends on proportional to your message signal m of t. Right? So now I can write the same equation AC cos of omega ct, and this phi of t, I said it is proportional to m of t. I will just write kp into m of t. Right? See, I'll just put it in the phase form only, phase shift form only. That means I am writing it as kp into m of t, message signal. This equation is called as equation of a phase modulation, right? Because I am just putting it as it is. I did not convert it into frequency. Suppose if I want to write the same equation as a frequency modulated wave, what is this component phi of t? What is the relation between phi of t and m of t? Just now I told you. What is that? That is AC cos of omega ct plus kf into integration minus infinity to infinity m of tau into d tau. This is the equation for frequency modulated wave. This is the equation for phase modulated wave. Now, if I give this, can you get this? You can, right? Integrate, right? If you give this, can you get this? What do? Differentiate. Have you understood now? Mathematically, you have understood. See, there is the relation between your frequency modulation and phase modulation. Both are same, but one is integration of other and differentiation of other. One is integration, differentiation of others. That is the difference between a frequency modulated wave and also phase modulated wave. So have you understood this? Frequency modulated wave and phase modulated wave. Right. So we get two equations now. Both are same. Okay. One is phase modulation. See, I told you, when phi of t is proportional to instantaneous value of the message signal m of t, your phi of t is equal to kp and m of t. So in this equation, replace phi of t by kp into m of t. So what you get? A equation, and this is called as equation of a phase modulation wave. Now same equation we write it in a different way using frequency. So phi of t, when you write in terms of frequency, it will become integration of m of t. So next equation is going to be this equation when phi of t is represented as a frequency. This is called as frequency modulated wave. This is called as phase modulated wave. Now can you get one from another? You can get, right? Now see here, you have to design FM modulator. Your ultimate purpose is to design FM, right? But assume that you have been given phase modulator. So what you will do now? How do you convert it into frequency modulator? Come on. Integrate. Whatever signal, message signal you have, you integrate and then give it to the phase modulator. Yes or no? Yes or no? Right. That is going to give you frequency modulator. See, you have a phase modulator given to you. Right. How do you convert it into frequency modulator? That means first you integrate the signal and give it to phase modulator. Right. So what you will get is the integrated version of the m of t, right? That is going to give you a frequency modulator. Now similarly, assume that you want to get phase modulator, but you have been given frequency modulator. So what you do with the signal? First you differentiate it and then you give it to frequency modulator. Have understood this, right? Because see, integration of differentiation, what you will get? M of t only, right? Yes or no? Try to understand this. See here, what I am trying to tell you is that what you want is the phase modulator, right? What is given as frequency modulator? What is the equation for this frequency modulator? AC cos of omega c t plus integration of k f into m of tau d tau, right? What you require here? AC cos of omega ct plus some constant kp into m of t, right? This is what required. This is phase modulation is required. Now what is there? Given is this one. This is a message signal m of t. Now to get this, what I require here? To get this, I need to differentiate first this m of t, right? So what I am going to do, I am going to get d by dt of m of t, right? That is given as the input here. Now see here, when this is given as an input here, you will get integration of differentiation, right? What will happen to integration of differentiation? It cancels, right? So you will definitely remain with another constant into m of t. And what is this, tell me? Phase modulated wave. This is phase modulated wave. Now similarly in the previous case, listen carefully, I am trying to explain you this. In the previous case, what you want? FM modulator, right? FM modulator, what is the equation of FM modulator? Remember this AC cos of omega ct plus kf into integration minus infinity to t, okay, m of tau d tau, yes or no? This is required for you. What you have here is phase modulation. What is the equation of phase modulation? AC cos of omega ct plus kp into m of t. Okay, now you have to get this. What you should do with the message signal m of t now? Integrate it. You first integrate it. So your m of t will become integration of m of tau d tau minus infinity to t. When this is given as an input, what will happen? Your m of tau t will be replaced by this. When your m of t is replaced by this, can you tell me what are you going to get? FM wave. Now have you understood how to get FM wave from PM and PM wave from FM? This is the way you get it. Either use integrator or differentiator. Get one from the other. That's why I told you this FM and PM is same. Both are same. Only the representation. That's all. Right? Okay. So now, if you see this, I'm going to show you a device. Okay. This is your FM wave equation. This is FM wave equation. This is the equation of a FM wave. Now, this is a walkie-talkie, right? This is nothing but your FM transmitter and receiver, right? Hello, hello. So can you just, some of you hold, I think you all know, you must have used in BSF, right? So, hello. You can talk. You press and talk. Hello. It was working. I don't know what's it. You are 9, huh? You change it. Put it in 9. Hello? Hello? No, volume you have to increase. Change the volume. Hello, hello. What is this? Tell me. This is noise. Okay? This is noise. Can you turn it, put it in 8? Hello, hello. Can you hear me? Hello? Power on. Don't know, something is changing in this. Put it in 8 only. Hello? Here, you can hear, right? Okay. Can you can talk. This volume, I think. Which is volume in this? I think I had. Power on. Okay, you can talk each other. This is FM. What you get in this is FM. Okay. The one unit has got both FM transmitter and receiver. Okay. Have you understood this? So we will see what is there inside. You increase the volume. Increase the volume. It's coming? But maybe some problem in there. Now it's coming. Very good, very good. Right? This is FM. Whatever you are studying, the wave which is generated from there is this one. Did you know this earlier? The wave which is generated, mathematically represented as this one. Have you understood? Right? That's a FM wave. How to generate this FM and how to demodulate the FM, everything we will see in this. Right? So here you just see what exactly you're doing. You are converting amplitude of the message to frequency variation, right? You have, see, your message signal is nothing but is a combination of amplitude variations. You're converting it to frequency. You're converting it to frequency variation, right? How to do that? One very important electronic circuit which is called as oscillator. I don't know you have come across the oscillator. I think by this time in third year you should have been seen these oscillators. I know it is there in the syllabus of microelectronics, but nobody teaches. It is there in the, I know, but whole time goes on teaching only common emitter, common base, right? Whole time goes on learning about MOSFETs, right? Multi-stage amplifier. Your entire microelectronics, you learn only amplifier. You will never learn any other electronic circuit, whereas there are so many electronic circuits which you're supposed to know, you are not studying. But in third year, next semester, you are going to study the continuation of your microelectronics, which is called analog electronics. Have you understood this? Okay? There you may be studying about oscillators. And what is the oscillator? Oscillator is a circuit which generates oscillations. Suppose I want to generate a sine wave. I can use an oscillator. I can design a sine wave I can design a circuit to generate a sine wave of say 100 hertz. Right? There is a circuit for that to generate only 100 hertz. Right? And that oscillator makes use of transistor with the transistor feedback circuits. Have you learnt about feedback circuits in microelectronics? Yes or no? What is feedback circuits? What is the benefit of having feedback in your circuit, in your transistor? To correct the error. See, so as to get a sustained oscillation, okay, you need to have a feedback, right? Suppose I want to, stand stable like this. How can I do that? I need to have feedback, right? Right. See, suppose if I want to stay permanently like this, how can I do that? Whenever I just check, I need to correct it myself. Same way, you are going to use something called tank circuit along with the transistor, right? The tank circuit will oscillate, right? And after some time it will get damped, right? To keep that, you give that output as an input once again, so that it will continuously oscillate. That is called as oscillator. Now, in this case, if I make that oscillator to oscillate according to my input, if my oscillator, instead of generating a sine wave which is constant frequency, if I change it to oscillate in such a way that all instantaneous frequency of the oscillation depends on my message signal, what you will get? FM wave, yes or no? You are converting your amplitude to frequency. So what we use to generate a frequency modulated wave in nothing but a circuit which converts your amplitude to frequency variation. That's all. That's what the circuit we are going to use. Then how do you demodulate it? You converted amplitude to frequency, right? What do you do in demodulation? Reverse. Convert your frequency to amplitude and give it to speaker. The same thing is happening in this system. Same thing is happening. You're converting your amplitude to frequency, frequency to amplitude. See, both are actually synchronized to be synchronized with the same frequency. He said 7, 8, 9. What is that actually? Do you know? Those are carrier frequencies. Those are carrier frequencies. So if both are actually in the same carrier frequency, whatever he speaks, he can hear. Right? Suppose if he is using some other frequency, some other device is tuned to that, he can speak to that. Yes. It should not clash. That's why this is not allowed outside. Within a range, this is okay. But not, of course, this cannot go for far distance. Satellite phones are having specific frequency. That's why satellite phones you need to buy the frequency for that. That frequency cannot be used by anyone. Have you understood this? That high frequency only, all are high frequency only. But which frequency you use, that's important. There are certain frequencies which are called as military, right?